What if Earth had not one, but two suns? How would the sky look? Would our seasons change? And could life as we know it even survive? Today, let's explore what science actually says, the orbital dynamics, the climate effects, and the possibilities for life under two stars. First, we need to understand how two-star systems actually work. In fact, binary and multiple star systems are common in our galaxy. About half of Sun-like stars have a companion. For planets in such systems, astronomers recognize two main orbital configurations: S-type or satellite type. The planet orbits one of the stars while the other star orbits farther away. P-type or circumbinary. The planet orbits around both stars together as if they were a single mass. Each case has very different consequences for planetary stability and habitability. The key question is, would Earth's orbit remain stable? In an S-type configuration, the second star must be far enough away so its gravity doesn't constantly disturb Earth's orbit. If it's too close, Earth's orbit could become more eccentric, leading to severe climate swings or even ejection from the system. In a P-type system, where Earth orbits both suns, the orbit must be well beyond the distance between the stars, usually at least 3-5 times farther, to avoid chaotic gravitational interactions. Small perturbations would cause long-term oscillations of Earth's orbit and tilt, while large ones could be catastrophic. The next factor is luminosity. The amount of energy Earth receives determines whether liquid water and life can exist. Astronomers use the concept of the habitable zone, the range of distances from a star where temperatures allow water to remain liquid. The habitable zone roughly scales with the square root of total stellar luminosity, AU/H/Z/L total. So if Earth had two stars exactly like our Sun, the combined brightness would double. The habitable zone would move outward by about 1.41 times. That means Earth would need to orbit farther away to maintain similar conditions. If the second star were a faint red dwarf, its contribution would be smaller in energy. But it could add other challenges, like bursts of ultraviolet or X-ray radiation. What about the view from the surface? In a circumbinary system, the two suns could rise and set at different times. Sometimes both would shine together, making the day brighter. Sometimes one would follow the other, creating extended daylight. Nights could be shorter, or even disappear for parts of the year. In an S-type system, the second star might appear as a smaller but bright second sun in the sky, like a permanent glowing companion. Seasons would also be more complex. The amount of sunlight Earth receives could vary depending on the orbital positions of both stars. Instead of a simple yearly cycle, the planet might experience overlapping rhythms, some mild, some extreme. More light, or more variable light, means a different climate, stronger winds, altered rainfall patterns, and perhaps more violent storms. Tides would also be affected. The gravity of a second star could amplify tidal forces, increasing geological activity. In extreme cases, additional tidal heating could trigger more volcanism or even alter plate tectonics. For life, double sunlight would bring both challenges and opportunities. If the two stars had different colors, for example, a yellow sun and a red dwarf, plants might evolve pigments that can use both kinds of light. Photosynthesis could shift to absorb more infrared or ultraviolet wavelengths. Circadian rhythms, the natural biological cycles of day and night, would also change. Organisms might adapt to two dawns, longer twilight periods, or irregular patterns of light and darkness. In the long term, much would depend on the type of the second star. If it were a massive star, it would burn quickly and eventually explode as a supernova, a deadly event for nearby life. If it were a red dwarf, it could last for trillions of years, but produce frequent stellar flares that bathe the planet in radiation. In close binary systems, mass transfer between stars can also occur, creating unpredictable and dangerous environments. Interestingly, astronomers have already found planets in binary star systems. The Kepler mission discovered several circumbinary planets, such as Kepler 16b, sometimes called the Tatooine planet because it really does orbit two suns. These discoveries prove that planets in binary systems are possible. So, what if Earth had two suns? It could mean brighter days, stranger seasons, and perhaps very different forms of life. But it could also bring instability, radiation hazards, and eventual destruction. The answer is, it depends on the stars themselves. Nature already creates such worlds, and they remind us how diverse and surprising our universe really is.